Hello, Flink Forward. How's it going? Yeah, a little tired after lunch? All right. Okay, we got our mandatory legal slide. All right, so who are we? I'm Caito Scherr. I am a software engineer, as Konstantin said, and I go by they or she pronouns.
And I'm Nick Davis, also a software engineer, and I go by he or him pronouns.
We work at New Relic, specifically in the Portland office, and I tried to get it. I think that's actually the floor that we work on. I didn't actually count that thoroughly, but I'm pretty sure. We're a data analytics company. Show of hands, anyone here from Oregon, West Coast? Oh, nice.
Nice.
I wasn't expecting that. Excellent.
Anyone here heard of New Relic?
All right, we got a couple.
Hands.
Anyone know what New Relic does? Nice.
Okay.
All right.
All right.
We will not quiz you until after the talk, I promise. So this is our Portland office. We're the little red dot on the left side there, and those are the rest of our offices in the US, or around the world, actually. And specifically, we work on this team. We are the Account Experience, or AX team, and we deal with all of our company's account-related business logic. So that touches all of our different products. And we're here because over the last year, we were put in charge of creating a new pipeline for tracking customer usage across all these products. And in this video, we're actually challenging our company's browser team to a dance-off. It's actually very authentic for us. So why are we here specifically, though?
Okay, Apache Flink, right?
Freebie. But in all seriousness, we are the first team at our company to have a production service entirely in Flink, or actually in Flink at all. So we're here to talk to you about the last 8 or 9 month process that we went through, the challenges we faced, and how we solved them.
Yeah, so at a high level, we think you can be successful in a new project if you follow a little concept called data-driven development. I'm not sure if we've coined it, but I don't know, it's how we like to think of it. So what this really means is it's just a lot like the scientific method. You come up with a hypothesis, you collect intentional data, and you use it to better your product. So specifically, we'll talk about 2 main methods, the theses, or the hypotheses they represent, and what data you can collect to inform your decisions and make good ones. And Caito?
And we're going to do that with 2 specific methodologies, including proving technical viability using a proof of concept, as well as letting the data from your Flink monitor really drive your development, and how we did that in our implications.
Cool. So at a high level, we'll look at the challenge that we had to solve, talk about proof of concepts, Flink monitoring, and I apologize in advance, this is an English idiom, I hope it carries. 20,000 foot view means an overview. So I just convert it to meters, hoping it would.
All right, so the challenge that we faced that led us to do this new service in Flink, which was, so remember how I said that we had customer usage was one of the main things that our team does? So on a high level, utilization at our company has gotten way more complex as we've grown. We've been growing very, very quickly, and we needed to track how our customers used our platform on an incredibly granular level across a lot of different products in order to bill more accurately.
Yeah, so let's take an example of our customer. Jane would download a monitor for New Relic, which would send her application data to us. Let's imagine that she's connected for about 2 hours from 9 to 11 a.m. Now, the whole time she's sending metric data, our goal is to track that she's used New Relic for 2 hours. So here's some pseudocode. This is Berlin time, for example. A couple messages coming from Jane's computer. You can see on the left, this represents 2 different hours. Our goal is really quite simple. We want to aggregate that. On the right, you can see the summary daily record, which shows that Jane's used New Relic for 2 hours. That's our whole point. That's our whole goal.
So on a simple level, we've taken the raw product data on the left here from our internal agents. We have 1 agent and 1 topic per product. We reduce it, then map it, yes, in that order, I promise, and then it's sent to our data store. So for this project, what this looked like is we had 2 Flink services represented by the lovely Flink squirrels over here. And the first squirrel ingests the raw agent data, as we saw in the last slide, does the reducing and mapping calculations on it, and then it passes it to another topic with additional product data already in it. This data is then aggregated daily, where it's then sent to the second squirrel over here, which then adds necessary decorations such as timestamps and account information before passing along to our data store. It's actually quite a bit more complicated than this, but we wanted to make sure it was really simple and meaningful for the slides. Data is keyed on hostname, account ID, etc., but we did make a specific unique key just for this pipeline so that we could track it across a huge amount of accounts and account hierarchies and products. But overall, this is still a very simple problem until scale. So if we'd only needed to pipe the data through the system that we saw on the previous slide, we could have used a lot more simple tools. We may not have needed something like Flink. However, we're ingesting 5 million messages, running 15 million operations, processing 3 gigabytes of data every single minute just for this pipeline. That's not even New Relic as a whole. In addition to that, we had to be able to process it really quickly, very accurately, and we had to make the entire system on a really tight timeline. So not only did we have all these technical requirements, but we also had to prioritize development velocity so that we could actually get the framework, get the system produced quickly. So that mattered a lot in how we picked our framework. So this led us to the decision that we needed a performance stream processing framework that could really do a huge amount of heavy lifting for us. Okay, so accuracy, development velocity, scale, and performance. A lot of buzzwords, but these were all the things that were incredibly essential to us in this project. So picking Flink helped a lot, obviously, but what did we do to actually make sure that we could hit all those requirements? So the first thing was the proof of concept. Our hypothesis here was that Flink was the right tool for the job. So let's go get some data and actually prove it, or disprove it, hopefully prove it. Okay, so first off, why are we talking about a proof of concept? This is a pretty common practice, and most of you probably know what this is. Doch, a proof of concept is, it can mean very different things to different people, and the impact, though, of spending the time to really get it right was something that our team really had to internalize throughout the whole process. So what it meant to us is that we're using it as a tiny working model of our production product. We also used ours as a way to compare different potential frameworks, which is kind of the more thorough way of how we ended up with Flink. The POC was actually very, very useful as the key component in our experiment-driven design. And as for the tiny working model, what does that mean in Flink to us? It means having a technically viable product mirroring the system that we wanted to create in production. And what that means is that even though our prototypes were on a very small scale and they did not have nearly the amount of complexity as our production goals, we needed to make sure we tested the essential technical attributes from start to finish. We call this a steel thread, which is essentially having that one single thread of functionality from start to finish of a system. So we simplified and miniaturized the entire thing. We didn't use business output models. We just tried to make sure that we can count the hours and store them. We modeled state, but not business logic. It was important to only build out the very most essential features, even though we were so excited to just get going on it. Okay, so why the POC? So we talked about proving that viability early. And by miniaturizing the components, it helped us to build quickly while maintaining scale and meeting those minimum but essential technical requirements. Make it quick, make it work. All right, so in order to have a really good, and more importantly for us engineers who are eager to get going on production, efficient, data-driven POC process, there's some pre-work. And namely, that includes defining how we're going to measure our data. This involved creating a really detailed set of requirements or rubric. For the initial project, we knew that we cared about time windowing, parallelizing, and development velocity in the form of things like maintainability, as well as some operational aspects like deployments and monitoring. We also needed to know what our failure modes were going to be, and if we could do the required testing. Although it wasn't a technical requirement, it ended up being equally important to us to be extra diligent about getting input and feedback from management, product managers, and other stakeholders involved in the process. This helped us to clarify things early on and add things to our rubric, like finding out that we needed to meet an 8-hour SLA or service agreement with our customers. This refers to the time at the end of a daily time window and the availability of the usage event within that time in our data store. So this gave us important information, like the fact that we needed to prioritize accuracy of the data over how fast that we could store it. So for some pure examples of this is our POC code. As you can see, this is a small part, but it's still very, very simple. This is one of the ways in which we proved out a steel thread for technical viability. So in this example, we're going to look at how we're doing what would turn into our maps and reduces. So in this case, we're just using a simple fold. So very, very simple. So our production code, obviously, it's a little bit more complicated. We've still blurred out a couple things just to really focus on the parts that we're talking about here. But specifically, you can see that the maps and reduces are quite a bit more complicated. We got map, reduce, map, 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 map. It actually keeps going, so we just cut that off for the talk. And in terms of making it quick, our example here is time windows. So as I said, we had a 24-hour period that we're actually checking the data. So that's really hard to iterate on when you're creating the entire system. So, obviously it's not great programming practice to hard code it, But in this example for our POC and our short temporary project, we put in a 3-minute time window, just hard-coded in there. And then we were able to iterate on that and test out and make sure that we could test it in multiple different environments to make sure that we could actually hit that 24-hour window by the time we actually got there. And then for our actual production code, you can see, so, like good little programmers, we abstracted out into an M class. We also created a script that automatically updates the text editor that we're using. We all use IntelliJ, and IntelliJ has a really good feature where in just 2 clicks, as long as you've piped it out to the configuration setting, you can just set it really, really fast, really efficiently. For the production code, this is actually the same file, as you can see. And you can see that we're actually calling it there, so it's quite a bit more complex. So really just wanting to focus on the fact that you are just breaking it down to the very, very bare bones for your POC. OK, so overview. I cannot emphasize enough how worth it is to really test out your tools and also make sure that you're using your tools correctly. You don't want to use a saw, a hammer, and a nail. You can. It's just a really bad idea. Don't do it. So really focusing on getting the testing done and proving your hypothesis early. And we want to make sure that having this, so part of why we had it, is we had confidence in our choice and in our roadmap, a deeper understanding of the framework that we'd be working in, making it easier to develop quickly for the rest of the project, and the groundwork was already done for us. This also meant that we could troubleshoot and address any issues that we would be dealing with later on in a larger system so that we could really spend the time in production focusing on the real features we wanted to develop quickly as opposed to spending all that time troubleshooting. All right, take it away.
All right, thanks, Caito. So at a high level, we talked about how to build a POC, what hypothesis that represents and kind of the scientific method, and what data you should collect in order to make a good decision there. So let's look at a second hypothesis. I'm sorry. I think this is an assumption you should make, though, that honestly, like everyone's code probably starts out sucking. You can see an imaginary job graph here. The point is that if you start with that assumption, you can really focus on collecting some intentional data, in this case from your Flink app, and it'll help you understand and make more informed decisions. So it's really not that complicated. I want to talk about it a little bit. It really comes down to 3 steps. This is pretty simple. So you do what you do normally. You deploy some code and you ship it. You write some code and you ship it. You add some monitoring. In this case, we'll talk about Flink Metrics a little bit. The third step is that you get feedback. So normally you're probably, I hope everyone here is familiar with monitoring in general. Hopefully you've had a chance to look at the Flink docs a little bit. We'll talk about that a little bit if you haven't. But here you might notice an issue. It might come up in your alerting. It might be something you just noticed by keeping an eye on the dashboards. We'll talk about what that means. So what do we actually track? We find some useful metrics. As Caito mentioned, we do state aggregation over a whole day. So state is really important to us. At a high level, we wonder how big it is, what trend it exhibits, how long the checkpoints are taking. We checkpoint every 2 minutes, so if the checkpoints are taking 60, 65 seconds, and really any duration even close to 2 minutes, that could be a problem. Throughput's interesting. You might want to look at different throughput, cutting through your job graph, all sorts of things. And watermarks, you could substitute latency here, really anything. You want to understand your stream time though, right? You want to understand what's happening, how data is flowing through your job graph. So the Flink Cluster UI is a start. It has some basic information. Technically, I think you can dive into just about any Flink metric there is in the web UI provided by the Cluster app, by the job manager. But ultimately, it has some limitations. What we really want is to be able to extract the data. We want to pull the data out, put it somewhere that we can query it and transform it, chart it, and find out things that we never would have otherwise. An example here is our watermark heat map. OK, so how? Like I mentioned, Flink has a great metric system, and you should use it. It's really not that complicated, and it does all sorts of wonderful things. You can pull out any metrics. You can add your own. Here, they'll be annotated. All the metrics will be annotated with things like job ID, task manager that they ran on, and all sorts of other attributes that will help you find meaning. So really, what does that mean? How can you use it? Well, you can use an existing framework. I think there was a great talk yesterday by Maximilian about using Prometheus. Now, in order to do that, it's actually really simple. The Prometheus agent ships with Flink. You would compile it and send it out with your Flink library. And then you're able to use that. I think it'll go ahead and start populating metrics into your Prometheus code base if you already have that set up. And you'll get a baseline of monitoring. So it's really not that much work. Now, in our case, us being New Relic, an application performance monitoring company, not everyone knew what that is, but effectively, this is what we do. This is our bread and butter. So we thought we'd write our own. In this case, it made sense to do that. We thought it was a good opportunity for a couple of reasons. One being that we could figure out how to create an agent for Flink and what that meant, and also it being an opportunity to see if we could better serve this community. So for those interested, we'll take a brief look at a couple of the important interfaces that Flink provides. There's the metric reporter interface. Now you can see at the top, notify of added metric is where you'll be notified of new metrics, the system metrics as well as user metrics. You can add this to a list and keep track of them in any way you want. And then in the Flink configuration, you can schedule how often the report method would be called in the scheduled interface, which this is effectively like an entry point for dumping your metrics on a periodic basis. So cool. So we have some data. This is actually our state over time. It's the checkpoint size, so it's not our exact state in memory, but it's very analogous. So in our application, like I said, we store state across the whole day. So what that means, at midnight UTC, you can see we almost instantly aggregate about 2 gigabytes of data, which is our baseline. And then as we see new computers throughout the day show up, on the right, we build up until we dump all of our data at midnight the next day UTC. Effectively, this is us tracking computers on a daily basis. So the point here is not really what the slide's about, but the point is that this is such an easy trend. It's exposed to you so much better than diving into the UI and clicking through and seeing what your current state size is. You can let that graph over time, but this is 1,000 times better. Okay, so you have some data. Now what? Honestly, keep using it. Like here's where you win. You need to start to dive into your data and understand it. And your first goal is really to find out what's normal. So what you would do, hopefully, is start to look into it, create a dashboard. This is actually our production dashboard. This is the New Relic Insights product, but regardless of that, whether you use Prometheus or New Relic, you should be able to do something like this. You should be able to start to build meaning into something that you look at. And again, your goal first is to understand what's normal. After that, really just keep exploring. So at this point, you should be able to create alerting. That's a pretty common thing, right? So your goal here is just to understand what's healthy, what's normal, and report on that. That's kind of all pretty common. One concept I want to talk a little bit about that I think is more important, though, is information radiation. So it's pretty simple. Your goal here is really just to keep consuming the data that your app produces. It's not that complex. So really, what you need to do is put your metrics somewhere useful. In this example, I showed a dashboard, but you can make that dashboard your home page so you see it on a regular basis. You could have a report generated so that you see your data on a regular basis. You could put your dashboard on a giant TV in your room, in your team room, or on a projector. The point is that you need to be continuously exposed to the data and hopefully investigate it in new ways that you hadn't considered before. I want to give you a little example here. Now, this is, again, the same graph as before, slightly different. If you notice, it kind of looks like we lost some state here. So I want to explain this briefly. We were building out a new feature in this pipeline, and this was in our staging environment, so this didn't hit customers. But I came in after we shipped a new feature, and I noticed the next day, as soon as the code had ran pretty much, that there's an issue. And now that's not something I would have noticed until a little bit later when we did validation. Instead, I noticed it as soon as it shipped, because I had this dashboard as our homepage, and it made a significant difference. Briefly, what happened here is the customer's timestamp came in, and we were trusting it, which was a mistake. So it progressed our Flink watermark quicker than we anticipated. And so some of the data in one of the streams actually ejected prematurely. The point is that we found it quick, we were able to fix it quick, we iterated and moved on. So to recap, get your data, look at it early, look at it often, and let that inform your development. A couple areas for growth that we've noticed just while we're talking about Flink monitoring. There's no distributed tracing as far as I know, and it can be difficult to look into Flink managed memory specifically. I want to talk a little bit about distributed tracing. It's just incredibly useful. Imagine if you had a record come out 10 seconds late out of your sync. Imagine if you could go back and work through that and actually trace it through every single operator in your job graph and know exactly what happened at each operator. It's not something that's really out yet. We're hoping we can imagine more about it and maybe get the community to think about it as well. The other end is that the metrics can be a little bit buggy. Don't be discouraged, but if you do see something like this, report it. This is an example from our dashboard. The yellow trend continues to appear and disappear. It's happened on a couple different metrics. It happens. We're all people. Just make sure if you see something like this, document it and submit it back to the community. So, a high-level overview. We talked a little bit about 2 important concepts that we think are both related to data-driven development, and they'll let you ship better code faster.
So the proof of concepts are so critical to understanding whether something is going to work for you and work for you in the way that you expect it to. They're just as important in understanding squishy metrics too, like developer ergonomics. One thing was we were so excited to jump into that production code and get these new frameworks going and ship everything in time. But again, in the end, we were so glad that we took the time to really understand our tools at the beginning with something like a proof of concept. Prove that technical viability quickly and initially, make it quick, make it fast.
Awesome. And in terms of monitoring, actually use it, learn from it, let it continue to help you grow. That process never really ends. And my whole point is that if you go beyond just getting some monitoring up, if you actually look at the metrics continuously, you'll learn from it, you'll stay in tune with your application, and honestly, you'll never be surprised.
One with the monitoring.
Yes. So thank you, everyone. Thank you for everyone that helped us prototype this deck and work through it. And keep in touch.
Cheers.
Thank you very much. I think we're already out of time, but we can take questions offline.
Yeah,
Pretty sure.
absolutely.
Yeah, come find us, whether at the rest of the conference or happy
Right
hour
now.
maybe.
Yeah.
All right.
Cool.
Next talk will be in 10
Thank you.
minutes, and see you then.